Today we're going to be learning about modeling with linear equations. So go ahead at the top of your composition book, write modeling with linear equations. Remember, at any time you can pause this so you can get down the information. So let's look at what the title means, because sometimes in math, if we don't know the words, the meaning of the words, we can't do the math. So let's look at modeling. Modeling does not mean you're walking down a runway with cool clothes. Modeling is going to mean real life situations. So we're going to be in real life here. Linear, remember that word line in there, makes a line. And equations are anything with an equal sign. So we've been working with y equals mx plus b. And remember, m is your slope. So m changes each time, so it's going to go up and over, up and over, and up and over. So you want to remember that word change with slope. And the b is your y-intercept, and we've worked with that. And the y-intercept is also always a constant number. It does not change. So it doesn't change. And also, when you did your graphing, it was your starting point on the y-axis. Starting point. Okay. So when we have real-life situations, like in business, it's really important to use graphs to see how much money you're going to make or how many supplies you might need. So you can really apply the linear equations to things that you're going to be doing in your future. So when we model, we're going to be looking at this slope and this y-intercept. Let's also look at the y and x. Remember, this is just your y-coordinate and your x-coordinate. We can plug in numbers for those. So when we're doing a real-life situation, let me give you an example. So a real-life situation would be we're selling tickets. So when you're selling tickets, let's say you have to pay a certain amount to get into somewhere, and each ticket is worth a certain amount. So we can apply that to this equation in order to find out how much money we would make at whatever we're putting on. So let's look at an example on the next page. And you don't have to change your page, I'm just going to do that. So Mrs. Jakes loves working out. She loves going to the gym. And she looked at different gym memberships. And she found this one place, and you had to pay a certain amount, like pay an introductory fee. And this was just a one-time fee. So it was like a deposit. Didn't have to pay it ever again. And the introductory fee was $50. So $50 in order just to start my membership. Then every month I would have to pay a certain amount. So they said every month I have to pay $15 in order to keep my membership. So I looked at that and I thought, wow, you know what, this would be a great time to apply this to linear equations. So I took my function form, y equals mx plus b, and I thought back and I said, you know what, I know that I'm going to be paying a one-time fee that's not changing. So I'm going to say not changing here. And that's my starting fee. So my start. So remember on a graph, that y-intercept, that doesn't change. It's always that number. And it's your starting point. So for this gym membership, I can put my $50 at my starting point because I have to pay that no matter what. So I'm going to put that 50 in for my B. Every month, I have to pay $15. So that means every month it's going to go up $15 from my 50. I start at 50. And then I add another 15 the next month, and another 15, and another 15. And so that's my changing amount. It's going to change every time. It's going to change the line of the graph. So I know that my slope changes. So I'm going to put my 15 in for my slope because it's going to go up 15 every time. And I put my equation, y equals 15x plus 50. That's the equation that models the situation for this particular gym membership. So if I wanted to graph that, remember, I do my y-axis, and remember, when you do your graphing, you really have to have your intervals. You can't just guess at where the numbers are. I'm going to go by tens on my graph because I have this 50 here, and that's awfully big. So here's my starting point. So I go up 10, 20, 30, 40, 50, and I put my line there. And then remember, your slope is rise over run. And let's put our slope right here. Let's make that into a fraction so I have a rise over run. And remember, if you want to make that into a fraction, you just put a 1 under it because 15 divided by 1 is 15. So my rise is 15 and my run is 1. So I'm going to go up 10, but then I'm going to go halfway because that would be half of 10, which is 15, and over 1, which is right, which is right there. So my line is pretty steep. And I'm sorry I can't do a straight line on this program. So I went to 50 and then I went up 15 over 1. The reason I didn't go over a whole 1 is because, remember, I'm going by tens. So that changes it. So let's look at another situation in real life. So the fall festival is coming up at Shadow Hills. And Mrs. Jakes is the room mom for the Spanish immersion program because my daughter's in it. So I was interested in how they sold tickets and things like that. So for the fall festival, you don't have to pay to get in. So there's no starting amount. But to get your tickets, each ticket is $2. So to play any of the games. So you have $2 tickets. But you don't have any that you have to go in with, like you don't have to get in through the gate or anything like that. So no entrance fee. So I thought, let's see if we can model this and we can find out how much money we can make for the fall festival. So I did my y equals mx plus b. And there's no entrance fee, there's no starting fee. And that would be here, right? The thing that doesn't change, the starting fee. So instead of having anything here, I can put a 0 or I can put nothing at all if I want. Every time I buy a ticket, it's going to be $2. So I'm going to make my slope, which is going to change all the time, $2. So y equals 2x plus 0. And let me write that a little more simplified. Y equals 2x. So in this situation, it would be nice to know, let's see if I sold 400 tickets. So let's have x be the tickets, number of tickets, and y is how much money you make. So let's say in this situation we sold 400 tickets. That's great. So I'm going to go y equals 2 times 400. So y equals $800. That would be great if we could sell 400 tickets. I'm sure they sell much more. So this is a way you can find out answers by just plugging in numbers. On the previous one, I did it by graphs, and you can look at the graph and see how much you make. So let's look at the y equals mxb again. So y equals mx plus b. Let's just look at what each one means. This is your starting amount. So if you ever have to pay a flat rate, if you have to pay an amount to get into somewhere, that's your starting amount. Let's say, and then for the m, This is the amount that changes, the amount that goes up or down. So if I were in debt, like losing money, I would use a negative number there, but we don't want to do that. So let's say I make $5 every time I sell a box of Girl Scout cookies. I would put my 5 in there, and X would be the number of Girl Scout cookies. So X is your number of items. And Y is money earned. So today you learned how to model real life situations. Tomorrow you're going to be creating your own real life situation. You'll do a practice one, and then you'll create your own. So if you have any questions, remember you're going to be doing those on the inquiry charts when you come in. Thank you. Have a good night.